All right, so in this video, we want to prove whether these functions are even or odd algebraically. So in order to do this, you know that if a function is even, f of x has to equal to f of negative x, and if a function is odd, negative f of x should equal to f of negative x. So we always test for even first because it's just easier. And then if the function is not even, we'll test to see whether it's odd. Let's start with this first question over here. Let's start with finding f of negative x. I'm going to replace my x cubed with a negative x cubed like that, and then plus, I'll replace the x with a negative x. Now I want to simplify this a bit. So negative x cubed is just negative x cubed because a negative value cubed stays negative. Positive and negative give you a negative. And then 2 times negative x cubed is just negative 2x cubed minus x. These two are definitely not the same. So let's test for odd. Let's find negative f of x. Negative f of x is just a negative sign and then the entire function inside a bracket, and then you distribute the negative into the brackets. That'll give me negative 2x cubed minus x. So if I compare f of x with f of negative x with negative f of x, these two right here, they're both exactly the same. So I can tell that this function is odd. Let's go to the second example over here. We have f of x equals 2x squared minus x. So again, let's do a test for even first. Let's find f of negative x. Negative x squared is just positive x squared because negative times negative is positive and x squared is just x squared, and negative make a positive. This is just 2x squared plus x. So these two are not the same. You can see here it's a negative, here it's a positive, so they're different. So it's definitely not even. So now let's test for odd. Let's find negative f of x. That's just a negative, and then with the original function inside a bracket. And if I distribute this negative in, I'll get negative 2x squared plus x. And if I compare these two over here, f of negative x with negative f of x, they are not the same either because there's a negative here and this is positive. So this function is neither even or odd because none of them, these two are not the same and these two are not the same, so it's neither. And let's do one final example. This is an absolute function over here. And let's do our test for even. So f of negative x is equal to the absolute of 2 times negative x plus 3, which is absolute of negative 2x plus 3. Now, if you wanted, you could simplify this a bit more by factoring out the negative and taking that out, but it's not 100% necessary. Let's do negative f of x to see whether this function is odd. That's just negative with 2x plus 3 in a bracket. And if I compare these two, it's a bit hard to tell, but these two are not the same. And I'll show you a simplification here to explain why. So let me factor this negative out over here. So I have negative, then 2x minus 3. And then we know from our rules of our absolute, if we have a factored negative inside, the absolute can just make it positive, which is just absolute of 2x minus 3. So now you can very clearly tell that these two are not the same, but even in this situation here, you can pretty much tell they're not the same. Although for absolute functions, I would suggest factoring out a negative, and sometimes these two might actually match up.